Hey everyone, and thank you for clicking on the video. Today we're going to be covering function properties. Basically what I'm going to be doing is defining these terms as simply as I can. So let's start with domain. Domain is basically all of your x values. Your range will be all of your y values. An increasing interval is anywhere where the function is increasing in value. Decreasing interval is anywhere where the function is decreasing in value. Continuous function is any function that you can draw without taking your pen off the paper. There will be no holes, so you can see this function is continuous. Is it a one-to-one function? A one-to-one function is any function that has one y value for every x value. A left-end behavior is what the function is doing on the left side of the graph. So as you can see on the left end, this function will be going to positive infinity. On the right end, this will also be going to positive infinity. So here I've answered these questions. So when you're reading a graph, you always want to start from the left to the right. So let's look at the x values for domain. You can see the x values would be from negative infinity to positive infinity. Range is your y values. So you can see the function exists anywhere from y equals 0 to positive infinity. Increasing interval, where is the graph increasing? Well, the graph is increasing from 0 to infinity. Decreasing interval, the function is decreasing from negative infinity to 0. Is the function continuous? Yes, there are no holes in the graph. Is it a one-to-one? No. Again, you can see if you plug in 2 for x, 2 squared is 4. But if you plug in negative 2, you also get 4, so that's not a one-to-one function. The left-end behavior, positive infinity, right end, positive infinity. Next is the Cuban function. This is the x to the third power. Again, your x values are from negative infinity to positive infinity. Range are your y values, negative infinity to positive infinity. Increasing. So this graph actually increases all the time. It's going from negative infinity to positive infinity. It's always getting bigger. Decreasing, it's never getting smaller, so there's no decreasing interval. Is it continuous? Yes, you can draw the graph without taking your pen off the paper. Is it one-to-one? Yes, every x value has only one y value. Left-end behavior, on the left side this is going down to negative infinity. On the right side this is going up to positive infinity. The square root function. So on this one you can see that the function only exists for values greater than 0. So we would say that x is going from 0 to infinity. The range is the same thing. There are no negative y values, so this would be from 0 to infinity. It is increasing again from 0 to infinity. Decreasing, it's never decreasing, so none. Is it continuous? We can draw this without taking our pen off the paper, but there are no negative y values, and you can't plug in a negative x into the square root of x, so we would say no. Is it a one-to-one function? This is a typo. It should actually be no, again, because you can't have any negative x values. The left-end behavior, there is none. Nothing exists on the left side. Right end behavior, it is going to positive infinity. Okay, so in these sets of problems we're introduced a new question: is the function even, odd, or neither? So an even function is any function that is symmetrical across the y-axis. You can see here that it does look symmetrical at x equals 3, but it's not symmetrical about the y. So it would not be an even function. An odd function is any function that is symmetrical across the origin. So this would also not be an odd function, so the answer would be neither. So let's look at the domain for this graph. This would be from negative infinity to infinity. Again, those are all your x values. Range would be from negative infinity and up until 2. Whereas the function increasing, the function would be increasing from negative infinity all the way until x equals 3. And then from x equals 3 to positive infinity, the function would be decreasing. Is the function continuous? Yes, you can draw it without taking your pen off the paper. Is the function 1 to 1? No, there are multiple x values that have the same y value. For this graph, this is what an absolute value of x graph would look like. Your x values would be from negative infinity to positive infinity. Your y values would be from negative 4 to positive infinity. Whereas the function increasing, it would increase from 1 to positive infinity, and whereas the function decreasing from negative infinity to x equals 1. Is the function continuous? Yes, you can draw it. Again, you can draw it without taking your pen off the paper. Is the function 1 to 1? No. Is the function even, odd, or neither? It's symmetrical, but not about the y, so neither. The next graph, we have a cubic function. So the domain for this function would be from negative infinity to positive infinity. The range would be from negative infinity to positive infinity. The intervals of increasing would be none. The function never increases. The decreasing would be from negative infinity to positive infinity. Is the function continuous? Yes. Is the function 1 to 1? Yes. Is this function even, odd, or neither? The function would be neither. It is not symmetrical about the y or the origin. Okay, so these sets of questions are asking you to list the domain in interval notation. So we've been doing that. X is between negative 2 and 5, including 5. So anytime you can include a value, you would use a bracket. Every time you can't include a value, you would use a parentheses. So the answer to 1a would be from negative 2 to 5. You would use a parentheses for negative 2 and a bracket for 5 since you can't include it. The next question is x is greater than or equal to 0 and x is less than 2. So for this interval would be from 0 to 2. Because x can be greater than or equal to 0, we can include 0 in the function, so we would use a bracket, and then 2 would get a parentheses. So here we have a number line. As you can see, on x equals negative 4, you can see that this point is filled in, which means you can include negative 4. And you don't see a hole until you get to x equals 2, so that means you cannot include 2. So your interval here would be from negative 4 to 2, so this should be a 4, but you would still use the bracket. This would be from 4 to 2 with a parentheses. D says x is negative, so this means that x can be any negative number that is not 0, so the interval would be from negative infinity to 0, parentheses on both. So this symbol is epsilon. This symbol just means that there exists or that there can be any x in the domain for all real numbers. So the interval would be from negative infinity to positive infinity. Again, here we have another one of the graph questions. So use this graph to identify the function properties, write in interval notation format. So first up is domain, which is all the x values. So where do the x values exist? Which x values can you plug in? So you can see here you can use any x values. There are no holes in the function. So the domain would be from negative infinity to infinity. You can't include infinity, so you would use a parentheses. Range, these are your y values. So you can see the lowest y value starts at y equals 0 and it goes up to positive infinity. You can include 0. There is no hole at 0, so you would use bracket 0 to infinity, close parentheses. The increasing interval, when is the function getting bigger? you can see that it is getting bigger from 0 to infinity. So you would write, and again, you can include 0, so you would write bracket 0 to infinity, close parentheses. Whereas the function decreasing, this would be from negative infinity to 0. If you're reading the graph from left to right, all the functions, as the x is smaller, the y's get smaller as well. So the main thing for interval notation is just remember that parentheses means that you can't include the value. If you plug in the value into the function, you won't get a y value. A bracket means that you can include that x value to get a certain y value. Alright, so that does it for this video. If you found this video helpful, please like and subscribe. If you have any other questions, you can write them down in the comments section, and I will try to explain it or maybe even make another video on the topic.